Okay, now revise here. Machine learning. Regression is a way to predict num. It helps us to find how one thing changes when something else changes. Linear regression is what? Linear regression, as I told, is used for predicting the continuous data. Okay, for predicting price, for predicting salary. Okay, if you have these kinds of problem, you can use a linear regression. So you can see we have a problem statement that age, okay, and salary. Age is the input and salary is the output. So here you can see we have a best fit line, and let's see how the things works in this. Now let's see how you actually create a best fit line. uh, here we have a equation for creating best fit line, which is y equals to mx plus b, and m is the slope, x is the data point, and b is the intercept, and y is the predicted point. you know X is the actual point and y is just a predicting point. And what is a slope? If I am changing the data variable in x, then how much should I change in y? Okay, I am changing the data in variable x, then how much should I change in y? What is the intercept? When value of x is 0, then where is the best fit line intercepting y? This is the intercept. What is intercept? When value of x is 0, then where is the best fit line intercepting the y? Okay, the how you can create a best fit line by changing the theta 0 and theta 1 value. You can create a best fit line by changing the slope, the value of slope and intercept. By changing, you can get a best fit line. Okay, we have initialize this values, which is slope 0.5 and intercepted 0, and then again we have use this value and then this. So we are getting the here best fit line. Okay, and we are getting the predicted point 0.75, and here we are getting this, and this here continuously we are getting the value. इस तरह से तो लाइक हेयर आई हैव राइट इन हिंदी, यू कैन सी इस तरह से तो अनलिमिटेड लाइन्स बन सकती हैं, बट विच वन टू चूज़? ओके, विच वन वी हैव टू चूज़? हाउ वी विल एबल टू नो डैट दिस लाइन वी शुड चूज़? थीटा 0 एंड थीटा 1 की वैल्यू को चेंज करेंगे और जो सबसे बढ़िया होगी वही लेंगे. ओके, so we will make a hypothesis here, like theta 0 plus theta 1 x, and this is intercept and slope. You can see theta 1 intercept, theta 1 is the slope, and theta 0 is intercept. Okay, but which value of theta 0 and theta 1 we will take? So here's you can see I have to find the perfect value of theta 0. I have to find the perfect value of theta 0 and theta 0 by making so many lines, and we have to check the theta 1, check residual error. Like we have to check the residual error. Okay, by using by using cost function. Okay, so cost function says uh, summation all the residual error, and here you can see we are अलग अलग लाइन का अलग कॉस्ट फंक्शन आएगा. ओके, so here we are finding the just loss, and if we are finding all the loss of the data point, then we will call it a cost function. You have to minimize the cost function by changing the theta. You have to minimize the cost function by changing the value of 0 by changing the value of theta 0 and theta 1. हम कैसे मिनिमम कॉस्ट फंक्शन पाएंगे? कौन से थीटा 0 and theta 1 की वैल्यू से? For that we use a gradient descent. What we will do, how we can get, we will use gradient descent. ग्रेडियंट डिसेंट कर्व जब बनाते हैं तो उसमें ग्लोबल मिनिमा पॉइंट को फाइंड करते हैं. हियर यू कैन सी वी आर जस्ट ट्राइंग टू गेट अ मिनिमम वैल्यू बाय चेंजिंग द थीटा 0 थीटा वैल्यू, बाय चेंजिंग द थीटा 0 एंड थीटा 1 वैल्यू. हमारे पास डेटा पॉइंट होते हैं, फिर थीटा 0 एंड थीटा 1 की वैल्यू को यूज़ करके कोई से एक लाइन क्रिएट करते हैं, फिर रेसिडुअल एरर निकालते हैं, उन सबको मीन स्क्वायर्ड एरर में डालते हो. आफ्टर डूइंग दिस आपको मीन स्क्वायर्ड एरर मिलता है. ये बोल सकते हो ये बोल सकते हो कि कॉस्ट फंक्शन मिलता है। ओके, mean squared error means for finding the for finding the one error. Okay, this is mean squared. If you are finding only one error, then this is mean squared error, and if you finding more than one, then we will call it a cost function. Okay, then we have to use a cost function. This one will give the most less error. Okay, here you can see we are just changing the value of theta 0 and theta 1, and then we reach to the global minima. Rm is to Rm is to reach near global minima, and we have to change the theta 0 and theta value until we reach to the global minima. And फिर उस कॉस्ट फंक्शन को आप एक ग्रेडियंट डिसेंट कर्व में कन्वर्ट करते हो, क्योंकि एक कॉस्ट फंक्शन नहीं मिलेगा, क्योंकि थीटा 0 और थीटा 1 की वैल्यू बहुत सारी हम लेते हैं। एंड ग्लोबल मिनिमा विल गिव द लेस्ट एरर, देन यू कैन यूज दैट थीटा value to create your best fit line. Okay, when we will get theta 0 and theta value, theta 0 and theta 1 value, then we will use that values to make a best fit line. And this is actually a linear regression mathematics. कैसे समझते हैं कि अब मुझे इसके नीचे साइड जाना है, उसके लिए हम यूज करते हैं repeat convergence theorem. Means how we will understand that we have to go now downwards. Okay, for that we use what? For that we use a repeat convergence theorem, and we have a learning rate, and we have to always take the value of learning rate, very low value of learning rate, because if you are taking uh, the value of learning rate a very large maybe, then you are not able to you are not able to get you are not able to reach to the global minima. So we have to just what we have to take the value of learning rate very low. Okay, तो हमेशा कम लेते हैं and this is our multiple linear regression, where we have a lots of input column, you can say, which is theta 0 is intercept, and theta 1, theta 2, theta 3. Okay, these are the slopes, and x1, x2, x3, these are the inputs. And this is our original data. Here you can see, and we are just taking, this is 100% data, and we are taking 80% data for training, that it can find a pattern and everything, it can understand how the things is related to each other. Then it predict we have to take the 20% data from the original data that we can test. Okay, so you can see this is how actually we work. And then we have a performance matrix. R2 square is a check how is your model, किस तरह से परफॉर्मेंस दे रहा है. we use R2 square. Okay, how is good is your model. Okay, how is good is your model, this is a R2 square. And R2 square is like 1 minus sum of residuals and sum of totals. Here you can see we have a formula, and हवाई के मीन से लाइन खींचा है. अब इससे साथ रेसिडुअल करेंगे. रेसिडुअल एरर कम आएगा क्योंकि वो डेटा के बीच में से जाती है. ओके, बेस्ट लाइन को रेसिडुअल कम आएगा क्योंकि वो डेटा के बीच से जाते हैं. और मीन वाले का रेसिडुअल ज़्यादा आएगा. मीन वाले का रेसिडुअल ज़्यादा आएगा क्योंकि वो बीच से नहीं जा रही है. एंड रिजल्ट विल ऑलवेज बी पॉजिटिव एंड डेसिमल. Okay, why? Because here we have a residual sum of total, this is a mean, and result will always be positive, and a decimal chota and pada. Okay, and what is the adjusted R square? Adjusted R square, like it varies with the R2 square. Like if you have a salary and age, then maybe you are getting a 82% R2 square, and maybe by after adding the location you are able to get 88%. And maybe you are getting a location, age, salary and sleep. If you are adding of sleep, then maybe you are getting 89%. But this is not good. Sleep is not a good column. Okay, or not a good feature or not a good input. These are some features which are not correlated, but still giving more accuracy in, but still giving more accuracy. But it will fail. We will when we will start to predict on new world data. Okay, and these types of columns give us the problem, creates a problem for us, and it creates a problem. And you can see adjusted score is number of rows, and p is the features, and r is adjusted r square. And this is how you can see the things increase, age, salary, location. And if you are adding the column sleeve, then we are getting more accuracy, but this is not correlated. And here you can see we have to see the relationship always when we are finding a linear regression problem, like r square and adjusted r square. If r square is 81 and adjusted r square is 79, then that's great. And here is also great. Okay, and but in the third we can see the accuracy is good, 89, but the adjusted r square is 86. This is a decrement here. Okay, then we have to see always this. If we have a this kind of problem, then it will create a problem for us. So model evolution rt square and adjusted r square. And let's understand, if we have a condition of overfitting or underfitting, okay, in our model. Okay, then we will use Legend Lasso for that. We will use Legend Lasso. लीज एंड रासो यूज करो. सो वी हैव कॉस्ट फंक्शन लाइक दिस. एंड जब हम रीज एंड लासो यूज करते हैं देन वी हैव अ, तो हम ऐसे पैरामीटर्स या फिर हाइपर पैरामीटर्स लाइक लैम्डा यूज करते हैं कि जो हमारे कॉस्ट फंक्शन जीरो आ रहा है, कि जो हमारा कॉस्ट फंक्शन जीरो आ रहा है वो अब नहीं आएगा. ओके, तो हम क्या यूज़ करते हैं, रीज एंड लासो. तो पहले इधर ऐसा था कुछ लाइक दिस, एंड हाइपर पैरामीटर यूज़ किया तो लाइक दिस हो गया. एंड हाइपर पैरामीटर यूज़ करने के बाद ऐसा हो गया. कुछ थोड़ा हो जाएगा जिससे अब एरर जीरो नहीं आएगा. ओके, अगर जीरो एरर आ रहा है इट मीन्स आपका ओवरफिट हो रहा है मॉडल. ओके, एंड लासो में लैम्डा एंड स्लोप लेते हैं. And then we have a projected car price prediction. Then now let's move on to the logistic regression. A classification algorithm. It is a type of a classification problem. It is used for classification problems, and a classification algorithm is a type of machine learning algorithm used to predict a category or a class label for a given input. Classification is the process of teaching a machine to answer questions like, is that a cat or a dog, or will this customer survive or not, बाइनरी क्लास और मल्टी क्लास. लॉजिस्टिक रिग्रेशन लीनियर रिग्रेशन की मदद से ही बनता है. बस उसमें कुछ साइज चेंजेस आ जाते हैं. लाइक हमारे पास वेट है यहाँ पर, बाय वेट है एंड ओबेस है. लाइक मोटा है कि नहीं, तो वेट इतना है तो ओबेस नहीं है, इतना है तो ओबेस नहीं है, 96 है तो ओबेस है. तो ये प्रॉब्लम है एंड हम इस प्रॉब्लम को देते हैं, ये सब वेट देते हैं अपने मॉडल को, देने बताता है कि हमारा ओबेस है कि नहीं. एंड लॉजिस्टिक रिग्रेशन, हियर वी हैव एंड where we make a line like squares. Okay, and in the linear regression we create a best fit line like straight line. And you can see डेटा जो 10 पहले हमने लिए, और यहाँ पर 82 63 यहाँ पर डेटा है कुछ इस तरह से. देन हमने यहाँ पर प्लॉट कर दिया कि 50% वाले उधर जो है वो ओबेस हैं, 50% वाले इधर जो है नॉट ओबेस हैं, यहाँ पर देख सकते हैं. एंड वेट 96 है, तो हमने देखा कि वेट अगर 96 तो 96 यहाँ आ रहा होगा, 96 यहाँ आ रहा होगा, तो वो क्या है इधर आया, यानी वो क्या है ओबेस है. सो हम इस तरह से देखते हैं, हम एक डिसीजन बाउंड्री टाइप का खींच देते हैं. एंड द मेन straight line that can be influenced because of an outlier. एंड इसमें आउटलायर इफेक्ट हो जाता है, आउटलायर इफेक्ट कर देता है हमारी मेन लाइन को। द मेन स्ट्रेट लाइन दैट कैन बी इन्फ्लुएंस बिकॉज ऑफ एन आउटलायर। पहले वही डेटा ओबेस आ रहा था, बट अब वही नॉट ओबेस आ रहा है। तो ये किसकी वजह से हुआ? ये आउटलायर की वजह से हुआ। तो हमारा अगर आउटलायर आ गया, यहाँ पर देखो आउटलायर है, तो हम सोचेंगे कि वहाँ से लाइन खींचे, ऐसे खींचेंगे। अब अगर हम देखेंगे किसी पॉइंट को, यहाँ पर जो था वो ऐसे आएगा, ऐसे करके यहाँ, तो वो क्या आएगा? अब नहीं आ रहा है, नॉट ऑलवेज आ रहा। क्यों? क्योंकि वो हमारे पास आउटलायर है। तो आउटलायर हमारी मेन लाइन को अफेक्ट कर देता है, ठीक है, किसमें? लॉजिस्टिक रिग्रेशन में। तो आउटलायर अफेक्ट द आर मेन स्ट्रेट लाइन, एंड द मेन स्ट्रेट लाइन that can be influenced because of an outlier. To create a best fit line, we use a theta 0 plus theta 1x. Okay, now understand. So the two main issue using a single linear regression for doing a classification task. Okay, this is, we are just using here a single what here. So the two main issues for using a single linear regression for doing classification task. First, outliers influence the what? State line. If you are using if you are using a single linear regression for doing a classification task, then you will face two problems. What? First is outlier influence the main straight line, and second is the result can be positive and negative. Okay, like this is a 0 and this is 1. If your outlier is here, and maybe we will get the point here, so this can be the outlier. It is affecting the outlier. Okay, it is means this point is outlier, and it is affecting are the values of 0 and 1, which is are labeled data, and it is affecting. So maybe the output will not come 0 and 1, it will maybe come, it will come more than 0, like 0.1, or it will come 1.5. so this is how actually works if you are using linear regression for a classification. If you are using a single linear regression for classification task, so one is influence the main straight line, and second is result can be positive and negative, means below the 0 and more than the value can come. It can display 0 and 1, which is a real value in output section. So prevent from all of things, we use line this means S, and we call this S curve shape, and also we can say logistic function. So we have to change this straight line and make it a logistic function or S shape provide करना होगा. So if we give your line S shape, we have to use the sigmoid function. Okay, if you want to change our line to S shape, then we have to use a sigmoid function here. Okay, what? So here you can see, again we can understand. So prevent from all of these things, we square the line, and we will call it S shape or logistic function. We have to change the straight line and make it a logistic function or S shape. We have to change the straight line and make it what? Make it a logistic function or S shape provide करना होगा. And so if we give your line S shape, and we have to use a sigmoid function. Okay, if you want to squeeze your line, like if you are converting your if you want to prevent from all of this thing, you have to use a line S shape. Like we have to call this S shape, and we have to use a logistic function. And if you want to use logistic function, then you have to use it. For that you have to use a sigmoid function first, which is a sigmoid activation function. क्या करता है ये? It will convert a straight line into square line. What? Sigmoid function what do? It basically what do क्या करता है? It will convert a straight line into a square line. And what is the formula of sigmoid function? What is the formula of sigmoid function? तो sigmoid function means ये change करेगा straight line into a square line. So here you can see we have a formula S theta of x and g and then in the bracket we have a theta 0 plus theta 1 x1. So this is our formula of sigmoid function, and the value of g is also something which is 1 upon 1 plus e raised to power minus z, and you can see that s theta of x will become 1 upon 1 plus e, and minus, if we will plot the value of, if we will put the value of here value of z, then it will become theta 0 plus theta 1 x1. And so these are the formulas, and logistic regression में भी theta 0 and theta 1 पर line depend करती है. Okay, so here we have a formula, and here we use e means equivalence numbers, a mathematical constant, and value is 2.71828. एंड किस काम के लिए यूज़ करते हैं ये वैल्यू? इफ it is the base of a natural algorithm, and it is used because sigmoid function comes from calculus and probability theory, where continuous growth and log properties involved. So e means gives a smooth curve, and it gives what? It gives smooth curves, and if you have a straight line and we have squares it will become like this. And if you are equivalence rule, okay, equivalence number, then we can easily squeeze it. We will make it smooth. Okay, so difference is what here in the logistic regression and linear regression. So we have to find the value of theta 0 and theta 1 to create a best fit line in the linear regression, and in the logistic regression we have to find the value of theta 0 and theta 1 to create a squeeze line. Oh, I got it. In the linear regression we have to find the best value of theta 0 and theta 0 and theta 1 value to create a best fit line, and for creating the squeeze line we have to find the best value of theta 0 and theta 1 value. And if we want to create the best fit line, we have to use a cost function in the linear regression. Why we have to use a cost function? Why we cannot use a mean squared error? We can use a mean squared error, but there is a problem for that. If you are using a mean squared error, means it means you have only one error. Okay, if you're calculating only one residual error, then you have to use a mean squared error. But if you have a more than residual error, then you can use a cost function. Okay, and in the logistic regression we use a log loss function. In the logistic regression we use a log loss function, and in the linear regression we use cost function. So in logistic regression we use log loss function, and लॉग लॉस फाइंड करता है डेटा पॉइंट्स के बीच में, बट यहाँ पे थोड़ा प्रोबेबिलिटी पर गेम खेलते हैं, एंड लॉस प्रोवाइड करता है। गोल तो एक ही है, सबसे कम लॉस चाहिए कॉस्ट फंक्शन में और लॉग लॉस फंक्शन में, दोनों में ही लाइक हमें दोनों में ही एक ही गोल है हमारे पास कि वी हैव टू फाइंड द बेस्ट वैल्यू ऑफ थीटा 0 एंड थीटा 1। एंड एरर ग्रेडियंट डिसेंट कर्व में देखो। ओके, एंड लॉजिस्टिक में भी सारा लॉस को सम करके ग्रेडियंट डिसेंट यूज करो। हाउ लॉजिस्टिक लॉग लॉस फंक्शन और बाइनरी क्रॉस एंट्रोपी, we can call it log loss function or binary cross entropy, anything we can call it. Okay, if you have a predicted point like 0 point like 69% chance that the guy is obesity. Okay, so but the actual is like 100% actual, 100% which is actual. This is a predicted and this is actual परसेंट चांस की ओबेसिटी है, एंड यहाँ पर परसेंट चांस है कि 69% चांस है। ओके, सो हियर वी विल यूज लाइक दिस, हियर यू हैव 50% ओबेसिटी एंड नॉट ओबेसिटी, सो हियर मे बी 69% एंड वी विल सी हियर लाइक दिस. So this is actual, which is 100% that he is obesity, and here we have 69 we are getting like this. So you can see the difference between actual and predicted. You can see difference between actual and predicted. So we have to calculate here log loss, and let's say predicted probability is 0.99 and actual is 1. Very less loss here if you have a, a very less difference here. You can see predicted probability 99 and actual is 1. Very less loss. Predicted probability 0.01. Okay, predicted probability 0.01 and actual is 1. Then very high loss here. High loss पेनल्टी लगती है, एंड पेनल्टी लगती है तो लॉग लॉस फंक्शन में कैलकुलेट विद, एंड अगर पेनल्टी लगती है तो लाइक वी विल कैलकुलेट विद द लॉग लॉस फंक्शन से. ओके, हाई लॉस पेनल्टी लगती है एंड पेनल्टी लगती है लॉग लॉस फंक्शन से कैलकुलेट विद हम मतलब लॉग लॉस फंक्शन से कैलकुलेट करते हैं. एंड लॉग लॉस का फॉर्मूला कुछ इस तरीके से होता है. हर एक डेटा पॉइंट में चाहूँगा एक्चुअल, प्रेडिक्टेड and m means total, and number of samples, actual labels, and predicted probability 0 and 1. 0 के और 1 के बीच में आएगी. इसी तरह सारे डेटा पॉइंट को करोगे, सबमिशन करोगे. यहाँ पर हम 1 है हमारे पास, एंड यहाँ पर प्रेडिक्टेड हमारा है और हमारे पास एक्चुअल है, तो लॉस इतना आ गया. सो ऐसे ही काम करता है ये सब चीज़ें. तो एंड प्रोबेबिलिटी डिस्ट्रीब्यूशन बिटवीन एक्चुअल एंड प्रेडिक्टेड W नॉट निकलता है, और दोनों में हमारा गोल रहता है कि लॉग लॉस निकालना है लॉजिस्टिक में, एंड रेसिडुअल निकालना है कॉस्ट फंक्शन से लीनियर रिग्रेशन में, एंड दोनों से ही ग्लोबल मिनिमम फाइंड करते हैं. एंड हमें परफेक्ट वैल्यू चाहिए होती है, जीरो थीटा 0 एंड थीटा 1 की परफेक्ट वैल्यू चाहिए होती है जिससे हम प्रेडिक्शन कर सकें. एंड क्लासिफिकेशन में पता लगाना होता है कि अपना मॉडल अच्छा है कि नहीं है. उसके लिए हम यूज़ करेंगे कन्फ्यूजन मैट्रिक्स. ओके, अगर आपको क्लासिफिकेशन प्रॉब्लम्स है आपके पास, तो हमें पता लगाना होता है. वी हैव टू नो दैट आवर मॉडल इज परफॉर्मिंग वेल और नॉट. सो फॉर दैट वी यूज़ evolution of model. We call it evolution of model and confusion matrix. First we have so here is actual and predicted. So this is actual and we have predicted, and predicted is 1 and actual is 1. So this is a true positive. This is really nice. And if I have actual 1 and predicted a 0, then this is a false negative, means actual 1 and predicted 0. Okay, if you have actual 1 and predicted 0 means सच में था, एंड बट प्रेडिक्टेड क्या हुआ कि नहीं था. so this is error. And our actually 0 and predicted is actually 0 and predicted is 1. actually 0 नहीं था और फिर कर दिया था. this is also a error. Okay, and this is actually 0 and predicted is also 0. Then this is true negative. Okay, this is type 1 and type 2 error. These are our good point, but these are our bad point. 10. We calculate multiple things from this confusion matrix. From confusion matrix we calculate multiple things like what accuracy, precision, call. So accuracy is what the percentage of correct prediction is accuracy. True positive, true positive, true negative, true positive, true negative, and false negative, false positive. Accuracy is 92%. And what is precision? Precision is out of all predicted positive. Out of all predicted positive, how many were actually positive? Use when false positive are costly. Use when false positive are costly. And we can ask to the chat GPT also, like what we have to use precision, recall, F1. Okay, we can ask to the chat GPT that in this data set what we have to see. Okay, we can paste our accuracy and everything confusion matrix to, and we can send it to the chat gpt. Okay, if we want safe result, out of all predicted positive, how many were actually positive? Use when false positive are costly. This is a true positive. Precision means out of all positives, how out of all positives, how many were actually positive. So true positive, true positive plus false negative. Use when how many were actually positive. So how many were actually positive means true positive and false positive. If a model predicts 100 emails are spam and 90 of them are actually spam, the precision is 90%. What is recall? Out of all actual positive, how many were actual positive? Out of all actual positive. Okay, out of all actual positive, 0, 0, 1, 1 true positive. Okay, so out of all actual positive, how many were actual positive? True positive. So true positive by divided by true positive plus false negative. So this is our out of all positive. Out of all actual positive, how many were actual positive? Use and false negative or acoustic disease detection, and per accuracy is 95%. F1 is what? F1 is harmonic mean of precision and recall. F1 score 2 into precision into recall divided by precision plus recall. Use when you want to balance between precision and recall. ये तीनों चीज़ को कोड में लिखने के लिए हमें पूछना पड़ेगा चैट जीपीटी से कि कौन सा यूज करें, विच इज़ इम्पोर्टेंट. So this is our the rule of our what our linear regression and logistic regression. And now we will meet in the next video for KNN and the left algorithms. Thank you.